Alright, question 10. We're having a look at this formula and we're proving some stuff about it. Technically, I think we're going to prove the addition rule. So, let's start off by trying to prove that this thing plus this thing equals this thing. So, we've got n factorial over r factorial n minus r factorial, which my r's look more like r's, plus n factorial over r take 1 factorial n take r plus 1 factorial equals n plus 1 factorial over r plus factorial n take r plus 1 factorial. Now, anytime you prove anything, you don't necessarily want to just go from the left and end up with the right. You could do things to both sides and end up with the left-hand side equaling the right-hand side. Let's have a look at these. I've got two fractions and I want to add them, so I want the lowest common denominator. First of all, I've got this one looking like this, so I'm going to unroll this one until I end up with something similar. And I've got this one looking like this. I've got this one, so I'm going to unroll the one on the right until it looks similar. So I've got n factorial over r factorial is the same as r times r take 1 factorial. And then I've got n minus r factorial plus n factorial over r minus 1 factorial times, well, n minus r plus 1 factorial is the same as n minus r plus 1 times n minus r factorial. And that equals, on the right, I've got n plus 1 factorial, which is the same as n plus 1 times n factorial. I've got r factorial, which is the same as r times r minus 1 factorial. And then I've got n minus r plus 1 factorial, which is the same as n minus r plus 1 times n minus r factorial. Okay, adding this stuff on the left. On the bottom, I want the same things on the bottom, so copy and paste this down here and leave myself some space. This one's going to be times, now the only thing that's not appearing on the bottom here is n minus r plus 1. And on the right-hand side of the left-hand side, you know what I mean. The only thing that's not appearing is r. And on this other side, I'm just going to leave it as I've got it for the moment, because hopefully the left-hand side of the equal sign will end up matching that. Okay, so now I've got n factorial times n minus r plus 1 over r times r minus 1 factorial times n minus r factorial plus n factorial times r factorial over r minus 1 factorial n minus r plus 1 n minus r factorial, and I'm going to put the r at the front just because then it looks like the left hand side, equals n plus 1 times n factorial. I may end up putting that back where it went. I cannot be bothered writing this. So I've now got the same thing on the bottom of both sides of my equation. That's good. That helps me know that I'm on the right track. On this side, I've got n plus 1 times n factorial. On the left-hand side, I'm going to expand this, n factorial times n, take n factorial times r, plus n factorial times r factorial. Oh, it wouldn't have been times factorial, it would have been just times r. Okay, so stuff's going to start cancelling out. Minus n factorial times r plus n factorial times r. I've got here n factorial times n plus n factorial over the standard thing on the bottom. N plus 1 n factorial. Standard thing on the bottom of both. you can see what's going to happen. I'm going to expand the top on the left-hand side, factorize the top on the left-hand side. I get n factorial times n plus 1. And that's the same as n plus 1 times n factorial. I've got the same thing on both sides. I'm done. Yeah, like once I write it, I'm done. And what we've actually proved there, B, what we've actually proven is the addition theory. So that was NCR plus NCR take 1 equals n plus 1 C R R plus 1? CR. Have I really proven that? Yes, I have, because it's simple. Yes. Nope, that's it. That's what we've proven. That's question 10.